Let's sketch the Lewis structure for OF2, also known as oxygen difluoride. We'll use these simple steps to accurately depict the Lewis structure of OF2. First, we'll sketch a rough diagram of the structure. Next, we'll represent the chemical bonds between the atoms. Then, we'll identify the lone pairs and mark them on the respective atoms, ensuring that each atom satisfies the octet rule. Finally, we'll calculate the formal charges for each atom and verify the stability of the final structure. To draw a rough diagram of OF2, we first calculate the total number of valence electrons and then determine the central atom. The total number of valence electrons in OF2 can be determined by summing the valence electrons of each atom in the molecule. Oxygen, a group 16 element, has 6 valence electrons, while fluorine, a group 17 element, has 7 valence electrons. In OF2, there is 1 oxygen atom and 2 fluorine atoms. Therefore, the total number of valence electrons is calculated as 6 plus 7 multiplied by 2, which simplifies to 6 plus 14, which equals 20. Thus, OF2 has a total of 20 valence electrons. The central atom in OF2 is determined by selecting the element with the lower electronegativity. From the periodic table, the electronegativity values of oxygen and fluorine are 3.44 and 3.98, respectively. Since oxygen has a lower electronegativity than fluorine, it is chosen as the central atom. Therefore, the rough sketch of OF2 should have the oxygen atom in the center, with the 2 fluorine atoms arranged around it. 2 electrons represent a single chemical bond. Therefore, we will place 2 electrons between oxygen and each fluorine atom. In this way, we use 4 electrons to represent 2 chemical bonds. Since we calculated a total of 20 valence electrons earlier, using 4 for these bonds leaves us with 16 unutilized electrons. Lone pairs consist of electron pairs that are not involved in chemical bonding. Remember that each lone pair contains 2 electrons. In this case, we have 16 unutilized electrons, so we can form 8 electron pairs and mark them as lone pairs on the structure. It's important to remember that both oxygen and fluorine are period 2 elements, so they cannot hold more than 8 electrons in their valence shells. Additionally, when marking lone pairs, always start with the outer atoms before marking the central atom. In the OF2 Lewis structure, each fluorine atom is assigned 3 lone pairs, while the oxygen atom receives the remaining 2 lone pairs. The current structure of OF2 shows that each outer fluorine atom, as well as the central oxygen atom, forms a complete octet, satisfying the octet rule. Now we will calculate the formal charges for each atom to determine the stability of the final structure. This is the formula we can use to calculate formal charges for the OF2 Lewis structure. Formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Simply input the data and place the values in to obtain the formal charges for each specific atom. For oxygen atom, valence electrons equals 6, non-bonding electrons equals 4, and bonding electrons equals 4. So, the formal charge will be equals 6 minus 4 minus half multiplied by 4, which equals 0. For each fluorine atom, valence electrons equals 7, non-bonding electrons equals 6, and bonding electrons equals 2. So, the formal charge will be equals 7 minus 6 minus half multiplied by 2, which equals also 0. The formal charges on the oxygen and fluorine atoms are indicated, and it is evident that no formal charges are present on any atom in the current structure. Therefore, this structure can be considered the stable Lewis structure of OF2. To represent a bonding pair, we draw a single line between the atoms. In this structure, one pair of electrons exists between oxygen and each fluorine atom, so we draw one line between them. This indicates that the OF2 Lewis structure has a central oxygen atom singly bonded to the two outer fluorine atoms. That wraps up our explanation of the OF2 Lewis structure. If you enjoyed this video, don't forget to like it, share it with others, and subscribe for more updates.